What do we know about the speaker driver inside a Bluetooth speaker? Is it just a simple component or a combination of engineering, physics, and sound? Where exactly does this driver fit into the speaker system? And what is it made of? And how has it become one of the most essential parts of sound systems by converting electrical energy into sound? In this episode of our Bluetooth speaker video series, we are going to take a closer look at the speaker driver and how it works. But before diving into its components, let's check what the marking on the driver actually tell us. I will put it, yeah, RA, most likely the manufacturer or brand name. TG511, this is the model number of the driver or speaker. Ohm is the unit of electrical resistance. So, what does 4 ohms mean? It means this driver resists the flow of electric current with a resistance of 4 ohms. In practice, this resistance applies to the driver's voice coil right here. And the amount of resistance determines how much current flows from the amplifier into the speaker. So, watt is the unit of power. So, what does 3 watts mean? It means this speaker can convert a maximum of 3 watts of electrical power into sound without getting damaged. So, in practice, if you push more than 3 watts into it, the voice coil might overheat, burn out, or the diaphragm could get damaged. But rating also gives you a clue about the intended usage. 3 watt is typically used in small driver, like those in Bluetooth speaker, radios, or small monitors. Now let's break down the main components of a speaker driver. We have the magnet, then we have the connection terminals here, the voice coil here, frame or basket, spider inside of that. I hope you can see it. And then we have a diaphragm. These parts work together to form a functional driver. Now we came to the magnetic part. Okay. The magnetic assembly of a driver consists of 4 main components. At the first, we have yoke. This is a thick, ring-shaped metal plate that serves as the foundation for the entire magnetic structure. So, it supports the assembly and contributes the magnetic field in the air gap. Its function is to guide the magnetic flux toward the pull piece and complete the magnetic circuit from behind. It also provides mechanical support and stability for the magnet and pull piece. So, why is the center of the yoke designed with a conical or recessed shape? The conical recess in the center of the yoke serves several critical purposes. At the first, we have focusing magnetic flux toward the pull piece. As the magnetic field passes through the ring-shaped magnet, it needs to be directed into the pull piece. The conical shape acts like a magnetic funnel, channeling the flux from a larger area toward the center, reducing magnetic reluctance and increasing the field strength in the air gap. The second reason is mechanical stabilization of the pull piece. The tip of the pull piece is typically welded or pressed into this conical recess. The conical design ensures a secure and firm connection between the pull piece and the yoke. And finally, we have preventing magnetic field leakage to the back. This design focuses the magnetic field forward toward the air gap, minimizing leakage to the outside. It ensures efficient use of magnetic energy in the intended path, reducing energy loss. The next one is pull piece, right here as you can see, and here. And also here. Okay, this is a shiny cylindrical metal component that protrudes from the center of the yoke, forming circular prominence in the middle of the magnetic assembly. Its function is to concentrate the magnetic flux in the center of the air gap between the pulpice and the yoke, creating a strong magnetic field. The flux passes through the pulpice and reaches the gap where the voice coil is located. So, why is the tip of the pulpice conical? This engineered design serves several purposes. At the first, right here, we have improved magnetic field focus in the air gap. The magnetic flux from the magnet enters the pulpice and is directed toward the gap. A flat pull piece could cause the flux to disappear or weaken. The conical tip concentrates the magnetic field lines more effectively toward the gap where the voice coil operates, resulting in a stronger and more uniform magnetic field. The next reason is better air flow. As the voice coil moves, air flows within the speaker's enclosures. A flat pull piece tip could cause turbulent air flow, negatively affecting sound quality. The conical tip facilitates smooth, gradual airflow and reducing mechanical noise. The next reason is preventing voice coil contact with the pulpice right here. Okay, when the voice coil moves close to the pulpice, a flat surface could lead to unwanted contact, causing friction or jamming. The conical design ensures the voice coil's edge maintain safe distance, reducing physical contact and extending the speaker's lifespan. And finally, we have enhanced audio performance. A more effective magnetic field design results in better frequency response, greater sound accuracy, and reduced distortion. The next part is magnet right here, and I hope you can see it right here. Okay, the magnet is typically positioned between the yoke and the top plate surrounding pulpice. Its function is to generate a permanent magnetic field essential for the driver's operation. And finally, we have top plate. This is the upper metal plate placed on top of the magnet. It is usually ring-shaped with a hollow center to allow the voice coil to move with it. Its role is to complete the magnetic circuit by guiding the magnetic flux from the magnet to the air gap where the voice coil is located. So, we talk a lot about magnetic flux. What is it? Yes, I hope you can see it. Magnetic flux refers to the total amount of magnetic field passing through a specific surface. In a driver, what does magnetic flux mean? And how does it move? Magnetic flux is the magnetic energy produced by the magnet, moving in a closed loop through the driver's metal components. When this flux interacts with the electrical current in the voice coil, it generates a force that moves the diaphragm. The path of magnetic flux is like that. At the first, starts from the permanent magnet. Then we have enters the yoke, okay? And then through the yoke, it is directed to the pulpice right here. And the flux then enters the magnetic gap, this yellow part, okay? And the flux passes through the gap and reaches to the top plate. And finally, through the top plate, the flux returns to the yoke, completing the magnetic flux loop and enables the voice coil to move in the gap. Magnetic flux combines with the electrical current in the voice coil to produce force. Lorentz law. So, we have another important part, and it is what is the magnetic gap? The magnetic gap is the small space between the outer surface of the central pulpice and the inner surface of the top plate. This is where the voice coil is placed and moves back and forth with high precision. Why is this gap important? This area is where the most intense magnetic field in the speaker is concentrated. The voice coil moves in this narrow space, and when current flows through it, the Lorentz force is generated and causing the diaphragm to move. If the gap is even slightly too wide, misleading, or if the voice coil makes contact, the speaker won't function properly or make it stuck. Gap dimension typically ranges from 0.2 to 1 mm. It must be perfectly uniform because the voice coil moves back and forth preciously within this gap. So, why do the magnet components have different colors? Let me minute. Yes, we have it right here. Okay, you can see now. Yeah. So, color difference are due to different materials, surface treatments, and coating and their roles. So, at the first we have pulpits and yoke here, usually made of soft steel, for example, low carbon magnetic steel. The shiny appearance comes from first, polish to focus the magnetic field and reduce friction with the voice coil, and second, maybe galvanized or plated to prevent rust. These two components are the innermost parts of the magnetic field and must guide the magnetic flux preciously. Their shyness indicates a smooth, polished surface. Now we have a magnet right here. It is typically a ferrite magnet with a gray-black pearls and matte appearance. The reason for this appearance is that ferrite magnets are made from sintered ceramic powders, iron oxide plus barium or strontium, and do not have a polished surface. Their appearance is always matte, gray, or black, and due to their ceramic structure, they don't shine. So now we have a top plate. Its color is usually a mix of dark gray on top and gold or greenish edges. This is because this component is also made of magnetic steel like the pulpits. The golden or greenish edges are usually due to a chromote zinc coating, which gives a golden green hue. This coating prevents rust and adds elastic appeal. Now, however, the top surface facing the diaphragm being in close contact with air and the magnet often oxidizes or darkens slightly due to magnetic field. The gray color may result from magnet adhesive, a thin layer of metal oxide or residual adhesive, and partial demagnetization over time. So we have connectors. Yes, let me minute to change them. Okay, we have it here. Yeah, we have connectors right here. Two wires coming out of the voice coil are connected to flexible, usually beige or golden color lead wires inside that. Okay, these wires run to the positive and negative terminals located on the driver's basket. From there, they are connected via positive and negative cabs to the amplifier on the speaker's main board. I hope you can see it. Yeah. Their function is to deliver electrical current to the voice coil. Note, lead wires are made of soft, flexible wire, standard wire, because they must move constantly with the cone and voice coil. But I want to show to you, I hope you can see it, this beige wire, okay? Now we came to the voice coil and coil former right here, okay? At the first we have a voice coil made of thin, enameled, coated copper wire, often red or gold in color. It creates a variable magnetic field when current flows through it. This wire moves back and forth within the magnetic gap when current flows through the voice coil. Then a magnetic field is generated. Then it interacts with the permanent magnetic field and finally producing mechanical motion. So now we came to coil former right here. Okay, this is the cylindrical tube that the voice coil is wrapped around. Its material can be compressed paper, aluminum, or captain, and it must be both lightweight and durable. Its function is to hold the voice coil, connect it to the diaphragm, and allow precise motion inside the magnetic gap. Now we came to the basket right here. The basket part got a bit bent and deformed because I had a hard time removing it. And the main metal frame that all driver components are mounted on. In small and Bluetooth speakers, it's typically made of pressed steel or aluminum. The lower part connects to the top plate and magnet, and the upper part connects to the upper components, for example, spider, cone, and etc. Its function is to provide the main structural support for the entire driver assembly. And now we have a spider inside of this. I hope you can see it right here, okay? A corrugated fabric piece glued to the coil former and basket, located below the diaphragm. It is usually beige, brown, or pale yellow in color. The material is typically fabric impregnated with phenolic resin. Its function is to keep the voice coil centered in the magnetic gap while allowing it to move back and forth smoothly. I want to show you right here. It is spider and it is basket, okay? Now we came to the most important part of here, okay? The overall name of this assembly is diaphragm assembly, or more simply, diaphragm. In dynamic drivers, the diaphragm typically consists of four main components. Dust cap, right here. The shiny cap in the center. A shiny dome-shaped cover glued to the center of the main cone. It prevents dust or foreign objects from entering the voice coil area. Protects internal parts from contamination, and usually made of resin-impregnated fabric, thin plastic, or compressed paper. Now we came to the cone, right here. The main cone is responsible for producing sound by vibrating and pushing air, thereby generating sound waves. It is typically made of black fiber, paper, polypropylene, composite, or reinforced foam. Its function is to vibrate the air and produce sound waves while moving in response to the voice coil's motion. Important scientific note: in some technical sources, only the cone is referred to as the diaphragm, but in technical and repair application, it is entirely correct to call this four-part assembly the diaphragm. And now we came to the surround right here. Okay, the flexible edge that connects the main cone to the basket and controls its movement. It's the outer circular layer that allows the cone to move forward and backward while keeping it centered. Made of foam, rubber, or polyethylene. Rule: its role is to allow the cone to move freely while keeping it centered and to return it to its resting position. Now we have a speaker basket gasket or foam frame gale right here. Okay, this one. Okay, a foam sponge or rubber strip placed on the outer edge of the driver's metal frame. Roles and benefits of this part. Vibration damping prevents the driver from vibrating against the enclosures, for example, a speaker box or wooden case. The second one is noise reduction. Blocks air leaks and unwanted sounds to maintain better bass and sound quality. The next one is mechanical protection. Prevents the metal edge from damaging the enclosure or frame when the driver is screwed in. And the next one is tighter connection. helps the driver fit more securely to the enclosure, preventing it from loosening. And materials. Soft foam, most common because it's lightweight and effective. Rubber for higher vibration or because it's more professional, and adhesive backed because it's easy to install. Additional note, when this assembly is attached to the voice coil and moves with it, it's called moving assembly or moving parts of the speaker. We've gone through the components and now the question arises. How does the driver work and how does it collaborate with the speaker system? The core principle is converting electrical energy into sound energy. What happens? Electrical current from the amplifier board flows into the voice coil. The parts we have here is voice coil, terminals, and circuit. The next step is the flowing current generates a changing magnetic field around the coil. This flows by Faraday's and Ampere's law. The next step is this varying field interacts with the parent magnetic field inside the driver. The key parts here are magnet, pull piece, and the top plate. Okay, the next step is the resulting force causes the voice coil to move back and forth. This movement is very fast, up to thousands of times per second. And the next step is 5. Since the voice coil is attached to the diaphragm, it moves back and front along with it. So here we have spider, surround, and cone. And lastly, we have this. This movement vibrates air molecules producing sound. So alternating air pressure equals to sound wave. Result, the driver acts like a fast air bomb that creates sound waves. So, how does the driver work when placed in a complete speaker system? Now we have it here. Okay. The role of the bags. Role of the enclosure. The driver produces sound on its own, but when placed in an enclosure, the following happens. At the first, we have prevent wave cancellation between front and back waves. The back of the diaphragm also produces sound. If the front and back of the diaphragm are exposed, the sounds cancel each other out. The next one is enhancing bass. Some enclosures help bass sounds be heard more powerfully. The next one is mechanical protection. Protects against impacts and dust. And the next one is sound direction control. The shape and opening of the enclosure can direct sound in a specific direction. The next step is improved aesthetics. Makes the speaker more visually appealing and portable. So, in a complete speaker system, the following components are present alongside the driver, right here. Okay? At the first, we have amplifier. Amplifies the ID signal before it enters the driver. The next one is battery. Powers the circuits and amplifier. The next one is Bluetooth module. Receives ID wirelessly from a phone or other devices. And finally, we have a control board. Controls volume, power on off, lights, and more. Where does the ID signal comes from? The driver alone does nothing because it first needs an audio signal from a source to enter the system. So what happens here? Yeah, I can see it. In our Bluetooth speaker, these input options are available. At the first, we have Bluetooth, digital audio from a phone or laptop. Then we have a memory card, stored music files. Then we have USB flash driver, MP3 or WAV files. The next one is AUX input or 3.5mm jack, analog ID from a phone, laptop or player or etc. And lastly, we have built-in microphone ID for calls or recording. They open this door and come in. But no matter the input type, the signal first goes to the main control board. The central processor detects where the ID is coming from and determines how it should be played. USB, Bluetooth, jack, or etc. The internal amplifier strains the weak ID signal so the driver can play it loudly and clearly. And input switch selects which input is currently active. And lastly, we have the speaker driver. Now that the amplified signal is ready, it's reached the driver. This is where the stage we previously discussed come into play. At the first, the electrical signals enter the voice coil. A varying magnetic field is produced. This field interacts with the permanent magnet. The voice coil and diaphragm move back and forth, and this movement vibrates the air and producing sound. Okay, now we have enclosure. Helps make the sound clean and powerful. Okay, in this video we start with the marking on the driver, examine its internal components, learn the role of each part, and finally saw how this combination converts electrical energy into sound. Maybe there are other things in this device we didn't mention that caught your attention. We'd love for you to share them with us in the comments. Don't forget to like and subscribe. See you in the next video of our Bluetooth speaker series. Bye for now!